Hello, welcome back to my video. Today I'll be doing IGCSE Addition and Mathematics Past Year Paper 06062 to October November 2018. This is question 8. Show that 1 over 1 minus sine x minus 1 plus 1 over 1 plus sine x equals to 2 tangent x secant x. So, of course, to make it clearer, what does tangent x mean? Tangent x can also be written as 2 sine x over cos x. And the secant x here can also be written as 1 over cos x. So you can rewrite the 2 tangent x secant x in this form, where tangent x directly equals to sine x over cos x, and secant x just equals to 1 over cos x. And of course, you can either choose to start from the right hand side, then you work your back way, then you do your working, and then you will go back to your this equations over here. Like from either you can choose going from right hand side to left hand side, or from left hand side to right hand side. As long as you can show the examiners that from either of the side you will manage to get the expression on the other side, then you'll be fine. So in my case, like in this case here, I chose to go from the left hand side to the right hand side. Usually I choose the side which involve more expressions here, so it's easier for me to manipulate. So all I did is to make them to have the same denominator. Notice that 1 minus sine s and 1 plus sine s, they're different. So all I did is to convert each of them into this particular form. Notice that even though I multiply the bottom by each other, they are still the same. This equation over here is still the same as this equation over here. The reason is because this is simply the simplified version of this equation, because 1 plus sine x, this entire expression here, can be cancelled with this one. So in the end, this can be also written as 1 over 1 minus sine x. So this is just another way of writing the equation. However, we need to do this to help us to get our right hand side, as you can see why here. So this step, I just simplify them by combining them together, because this is a minus sign over here, and here we also get a minus sign, so they end up being a positive over there. And after that, you just have to do the multiplication over here, and you will get 1 minus sine square x. Notice that this form is also very similar to, I'm gonna put a note here, a minus b bracket multiplied by a plus b. And this sort of multiplication will usually give us a squared minus b squared, which is very similar to the calculation that's involved over here, how you change from this two bracket as you expand to end up here. So knowing this rules will help you save time in your exam. And on top over here, the 2, 1 minus 1 just got eliminated, and then positive x sine x plus another sine x will give you 2 sine x, because there are 2 of them now. And you may end up in this form, because as you can see, when you write each of them separately in this way, we can actually link them together when we have come to this step of calculation. And to change the form of your answer in this form to this form, all you have to do is to split them like this, because you need to show the examiner clearly how 2 sine x over cos square x is just equals to 2 tangent x and secant x. And to do that, all you have to do is to first split them into a tangent where sine x over cos x is basically equals to tangent multiplied by secant x, where secant x is equals to 1 over cos x. If you like to, you can also write down the basic rules like at the side here, like empty spaces over here. You can just write down that tangent x is equals to sine x over cos x, and secant x equals to 1 over cos x. So these are the notes that you may choose to write down to help you with this question. But after you have write down the rules of tangent x and secant x, and when you have come to this step, you know that you have to take the cos sign out from this expression in order to rewrite it in this form, which is exactly same as the right hand side over here. Hence, at last, you may write down here right hand side, where this is basically the right hand side of this equation up there. And moving on to the second part, hence solve the equation that's given, that asks us to solve on top over here, except that it's the same, and then where this is equals to cosecant x for all the x within the range from 0 degree to 360 degree. And this is a 4-mark question again. Again, before you do anything, check your calculator that your calculator is giving you the answer in the form of degree instead of radian. And since we have found that this equation that involves two different fractions can be rewritten as 2 tangent x and secant x, hence we know that actually this equation over here is equals to 2 tangent x secant x. So we may rewrite it in this form because all of them equals to each other. But in the second part here, we don't have to show the examiner that how do we get from here to cosecant x, because they already tell us they are equals. So all we have to be careful of, all we have to worry about is, of course, to manipulate tangent, secant, and cosecant, all of them into one sign that we can mathematical trigonometry symbol, or sign that we can be used to calculate the angle. And that's usually either tangent or cos or sine, one of them. And to do that, we rewrite them into form of cos x and sine x again. Cosecant x equals to 1 over sine x. It will be useful if you can just remember. And of course, this part over here is just the part over here in the first part. One of the equations that we'll be using to solve, to prove the 2 tangent x secant x. I just got it from the first part of the question. And again, when you multiply sine x to the right hand side here, to the left hand side, you will left with 1 on the right hand side, and the left hand side you will actually get 2 sine square x over cos square x. And after that, you notice that sine, it's kind of straightforward now that sine x over cos x is tangent x, and since they have a square on both of them, then we know it's just tangent square x for the part that involves the trigonometry. And then all I did is to move the whole number 2 to the bottom of 1, because I need to divide the entire equation by 2 to get rid of the 2 in front of this tangent. And to divide by 2 on the left hand side, I also divide by 2 on the right hand side. Hence, this is the equation that I get. That tangent x can be either equals to positive or negative 1 over square root of 2 because this is a square. So when we square root the 2, we can either get a positive or negative value. And we have to consider both positive and negative 1 over square root of 2. Well, all the bottom part of the calculation may seem complicated, but we can always start from looking at the diagram over here again. This is the trigonometry diagram that usually your maths teacher will ask you to use when during your exam. Since in this question we involve tangent, we know that when you press your calculator, when you press your equation, tangent -1 bracket, let's say we look for 1 over square root of 2 first. In this case, we consider the positive number first. And the angle, the x value here, it just directly equals to the x value you'll be getting over here, where A stands for or, S stands for sine, T stands for tangent, C stands for cos. And since this is tangent x, we have to consider the angle that's in the tangent as well, in this tangent region as well. So this is 180, the straight line over here is 180, and here is 0 for the first period. But if we go from 0 to 180, and if it's go back to 0 again, it can also be 360. And if we go another round, it will be 360 plus another 360. So this is how you go, as you will go forever to infinity. Since this is like similar to the graph of cos and sine and tangent, this is the period. They will go on forever. This is why they will always give us a range when they ask us to find the x, because if they do not give us a range, we will have infinite different answer for our x. And in this case, we just have to consider one period from 0 to 360. And since tangent x can be equals to both positive and negative, 1 over square root of 3, I will consider the positive first. When you press in your calculator, you will get 35.3 degree. And immediately write them down, because that's definitely one of the correct answer you will be getting is within this range. And then show on your calculator, just write that down. And of course, another answer is that you have to take the value from your t region over here, the tangent region over here. All you have to do is to plus your 35.3 with 180. Since to calculate any angle that falls in here, all you have to do is to plus the calculated value using your calculator with 180 degree. And this is how you get your first two answers. And of course, you have to consider another possibility where is definitely will be equals to tangent x may be equals to 1 over negative square root of 2. And in this case, you can definitely press the negative into your calculation, but you'll be getting a negative value as well, which is out of the region, 0, because your answer must be a positive answer that's smaller than 360. Hence, you mustn't include this in your answer, but you can write that down. Your x will be equals to, of course, first of all, the regions over here, 180 plus your x. And your x here in your calculator, it shows a negative answer. Just put a negative answer over here. And you will get 144.7. This is one of your answer. Write that down. And of course, your last angle will be found with 360 degree minus 35.264. How do I get this? First of all, the answer pressed in your calculator is simply a value in negative, which means that the angle is less than negative. So it will be in this region. But even though notice that this is a cos region, but then we don't have to consider about that much, because this is the value that we have gotten. when we calculate our first angle, like with the angle that we found using our calculator, no matter it's positive or negative, we just have to notice that if it's negative, means that the angle is actually below this horizontal axis. And it doesn't matter which regions it falls in, it's still being treated as x. Okay, notice that the x here and the x here is different, huh? This x here it may be the same, but then the x that we want to find here can be a lot of different answer. But this is the x, means that the angle that you find using your calculator. And all you have to do is to consider, because in the first period, when it goes from the first round, it's negative, means that it's over here. But then when it almost comes close to the second period over here, we have to use 360 again minus plus the angle over here, which is, in another word, this angle that we found should be in the second period, but then because this is a negative value over here, as 360, instead of 360 plus x to find the angle in the second period, it is a minus over here. Hence, it's still less than 360 degrees over here. Hence, we still need to write down our answers for this case.